Previous session, we studied polar coordinates. Plot the point with the polar coordinate. Sketch the polar curve by using polar equation. Now, we study calculus with the polar coordinates. I'm gonna give two main concepts here. First one is find the area of regions bounded by polar curves by analyzing how the radius changes as the angle varies. Second part is we're gonna find arc length of polar curves by examining how the curve grows and moved as the angle increase. This is all about polar curve R is f of theta. We're gonna find the area of region and find the arc length. Before we start with area of region by polar curve, let's review area about sector. What is a sector? Sector gonna be part of circle. So here is a circle. R is radius. This is angle of sector. How gonna find this area? The shade area. So we're gonna use a ratio, guys. If here is area of a circle pi r square, we're gonna use center angle. So what do you have here, guys? So 2 pi gonna be angle of center from here to here. That's the 2 pi. That's 30/60. Area gonna be circle pi r square. Now, this sector, part of circle, we wanna find area of A. Angle gonna be theta. Area gonna be A. So we wanna solve this equation, find the area of a sector. Cross multiply, we're gonna do it. 2 pi A equal pi r square theta. Okay, 2 pi L. A equal pi r square. We're looking for the A values. So we have divided by 2 pi. Area of sector gonna be pi r square theta divided by 2 pi. Pi's cancel out. Area of sector gonna be 1/2 r square theta. That's the area of sector. We want to find the area of region R bounded by theta equal A, theta equal B, R equal f of theta. So how gonna find this area of A? Idea is theta is independent variable. We're gonna slice angle B minus A, slice angle B minus L into the small piece. So that's we're gonna do it. Angle B minus A, that's the total angle. We slice it. So draw the line between the theta equal A, theta equal B. Then you have find the small sector. So this one is delta theta, small piece of angle. We want to find the area of this sector. So that's gonna be, we derive the formula for area of sector, 1/2. This is delta AI. We're gonna find it, 1/2. Radius gonna be from the here to here. That's the f theta star square. That's the r square times angle, delta theta. How gonna find the area? A, we're gonna add all the small area of a sector and take a limit. That's you're gonna find the area of A. So how gonna find delta AI? Delta AI gonna be 1/2 f theta star square delta theta. That's you find it. So limit and approach to infinity, summation 1 over 2 f theta star square delta theta. That's the area of region R bounded by theta equal A, theta equal B, R equal f of theta. What do you find the previous slides? Area of A for the region R bounded by theta is A, theta is B, R is f of theta. So how can find the area of A? Limit summation delta A, I, small piece of sector. Then that's going to be find 1.5 f theta star I square delta theta. Let's change this into integral rotation. Limit and summation change integral. Interval going to be of theta, angle A and B, 1.5 f theta square d theta. So this one is area bounded by r equal f of theta, theta equal A, theta equal B. Another way to write this one is 1.5 A and B r squared d theta because r is f of theta. Let's have first example to find area enclosed by polar curve. They asking here, find area enclosed by one loop. They have 1, 2, 3, 4 loop. So I picked this one. Okay, that's the one loop. Start is 0, theta is 0. Go to theta is pi over 4 because you plug in theta is pi over 2 here. That's cosine pi over 2 r equals 0. So theta is pi over 4 r equals 0. That's the here 0 and pi over 4. That's r is gonna be 0. The other side is symmetry. So here is theta equal minus pi over 4. So we have area gonna be 1.5 negative pi over 4 to the pi over 4. That's the one loop. We want to find the area. Now, look at this. 0 and pi over 4, 0 and negative pi over 4. These two areas exactly same. So I'm going to use 0 and pi over 4 u times 2. So 2 and 2 is cancel out. 0 and pi over 4 cosine square 2 theta d theta. Power is even, trigonometry integral. Trigonometry integral, you have power reduced form. That's gonna be 1 plus 2 theta double 4 theta d theta. Now, you separate denominator 1.5 plus cosine 4 theta over 2 and d theta. What is antiderivative 1.5? That's the 1.5 theta. Cosine derivative is sine. Here is 4 theta. You have need 4 is denominator. But when you plug in the pi over 4 here, first one is 1.5 pi over 4. Second is 4 times pi over 4 is pi. Sine pi is 0. When you plug in theta is 0, 1.5 0 is 0, sine 0 is 0. So your answer gonna be 1.5 times pi over 4 pi over 8. So one loop is pi over 8. You find the area 4 loop. You're going to times 4. Before we do another example area, let's practice this one first. Now, you have two polar curves. First one is r equals sine theta. Second is r equals 1 cosine theta. So we want to find point of intersection. Intersection is right here. Another one is right here. On the graph, you can find the intersection right away. First one is, what is the angle here, guys? The first one is angle gonna be theta is pi because here is a positive theta is 0. That's going to the pi over 2. So let's check it out. Theta is pi over 2. R is sine theta. Sine pi over 2 is 1. R is 1. Exactly, R is 1. Second polar equation, R is 1 plus cosine pi over 2. That's going to be cosine pi over 2 is 0. That's 1. So theta is pi over 2. R value is the same. That's the intersection point. Second is, you see second point here, origin. You might think theta is 0, but it's not. If theta is 0, sine 0 gonna be 0. So r equals 0. That makes sense. But r equals 1 plus cosine 0, cosine 0, 1. R equals 2. That's the theta equals 0 point. So this one is might be start here, go all the way here. That might be pi. So let's try theta is pi. R equals sine pi gonna be 0. R equals 1 plus cosine pi. Cosine pi is -1. That's the 0. So R value is 0. Theta equals pi. So you find intersection point here and here. Let's have another example. Find the points of intersection of two polar curves. R equals, first one is R equals 3 cosine theta. The other blue one is R equals 1 plus sine theta. How gonna find the intersection point right here and the other side? It's not easy to find intersection point from the graph. So this one is should be R is the same, theta is the same. R should be same, meaning is you put the equal. 3 sine theta equal 1 plus sine theta. You're gonna solve for theta. So move the sine the other side. 2 sine theta equal 1. Sine theta gonna be 1.5. Here is point gonna be quadrant 1, quadrant 2. Theta gonna be pi over 6, 5 pi over 6, right? That's the quadrant 1, quadrant 2. So let's find the R value. Theta is pi over 6. R is 3 sine theta. 3 sine theta pi over 6. 3 over 2. Sine pi over 6 is 1.5. Theta is right here, pi over 6, 3 pi over 2. Pi over 6, 3 pi over 2. Second is theta is 5 pi over 6. R is going to be 3 sine theta. That's going to 3 sine pi over 6. That's going to be same value is pi over 6. That's going to be 3 over 2, 5 pi over 6. Now we want to find the area between the two curves. Between the two curves, first one is here, second is outside. Outside the curve is R equals sine theta. Inside the curve gonna be R equals 1 plus sine theta. We want to find the area between the two curves. I find the intersection point. Theta is pi over 6. Theta is 5 pi over 6. So outside gonna be A1. That's the outside, guys. Inside gonna be A2. So find A1 first, guys. A1 meaning is 1.5 pi. So where is the stop on? Theta is pi over 6 to the 5 pi over 6. 3. R is 3 sine theta square d theta. A2 gonna be inside the curve. That's A2, 1.5. Pi over 6, 5 pi over 6, 1 plus sine theta square d theta. But our area between here is outside, that's the A1, inside A2. Find A meaning is A1 minus A2. So we have 1.5 pi over 6 to the 5 pi over 6, 3 sine square theta d theta minus 1.5. 5 pi over 6, pi over 6, 1 plus sine theta square d theta. So we find the area between two curves. A gonna be integral 1.5 pi over 6 to the 5 pi over 6, 3 sine theta square d theta minus 1.5 pi over 6 to 5 pi over 6, 1 plus sine theta square d theta. I'm going to put together this integral. So 1.5, 5 pi over 6, pi over 6, 3 sine theta square minus 1 plus sine theta square d theta. This one is a foilet. That's going to be 1 plus 2 sine theta plus sine square theta. So we have 9, 3 sine theta square gonna be 9 square theta minus 1 minus 2 sine theta minus sine square theta. 9 sine square theta minus sine square theta. That's gonna be 8 sine square theta minus 1 minus 2 sine theta. So how gonna evaluate this one, guys? The sine square theta, the power is even, we're going to use a power reduced formula of 1 minus cosine 2 theta. So you have 8 times 1 minus cosine 2 theta over 2. That's you're going to have 4 minus 4 cosine 2 theta minus 1 minus 2 sine theta. So 4 and negative 1 going to be 3. 3 minus 4 cosine 2 theta minus 2 sine theta. Let's find the antiderivative of each. 1.5, 3 theta. 4 cosine 2 theta, antiderivative going to be 2 sine 2 theta. Antiderivative sign is negative for positive cosine theta. 5 pi over 6, pi over 6. When you plug in, you have only, here is sine 2 times 5 pi over 6 minus sine 2 times pi over 6 gonna be cancelled out. Same thing is here. So you have 3 times 5 pi over 6 minus 3 times pi over 6. So you have right here 3 times 5 pi over 6. Simplify, that's going to be 5 pi over 2 minus pi over 2. So this one is 4 pi over 2. That's the 2 pi. 2 pi times 1.5. That's going to be pi. Let's pay attention to the arc length for polar equation. Arc length L of curve C, when I have this from polar equation, x equal ft, y equal gt, t gonna be between alpha and beta. That's we have integral alpha and beta square root dx dt square dy dt square dt. That's gonna be arc length for parametric equation. Now, we want to drive polar curve r equal f theta. Theta gonna be between A and B. What is gonna be arc length? We're gonna drive arc length formula for the polar equation. Here is polar curve. Theta is A and B. R is f of theta. So x gonna be r cosine theta, right? So r is f of theta, function of theta. So y equal r sine theta, right there, guys. So we want to find the dx d theta because this x depends on theta. We have using product rule. So take derivative r first times cosine. Take derivative cosine second. First dr d theta times cosine theta plus r times derivative cosine is negative sine theta. So you have dr d theta dx d theta gonna be dr d theta cosine theta minus r sine theta. We use product rule. Same thing here. dy d theta gonna be take derivative r first, product rule, dr d theta sine theta plus r times derivative sine is cosine theta. So we find dy d theta gonna be dr d theta sine theta plus cosine theta. So arc length for parametric equation gonna be dx d theta square dy d theta square. So I want to start dx d theta square, which meaning is dr d theta cosine theta minus r sine theta square. Let's first term 2 times first term, second term plus second term square. So we FOIL it. dr d theta square cosine square theta minus 2r dr d theta sine theta cosine theta plus r sine theta square r square sine square theta. dy d theta gonna be dr d theta sine theta plus r cosine theta square. So first one is drd theta squared sine squared theta plus 2 times drd theta sine theta r cosine theta plus r cosine theta square r square cosine square theta. Now, we have added. You want to add dx d theta square plus dy d theta square to find arc length. You want to add it. So dx d theta square plus dy d theta square equal this one added together. Meaning is, what is common factor? dr d theta square cosine square theta sine square theta. That's how I write it. Here is the second term, dr 2r dr d theta sine theta cosine theta d 2r dr d theta sine theta cosine square. Exactly same term, different sign. That's cancel out. Here is r square sine square theta plus r square cosine square theta. R square is common factor. Sine square theta plus cosine square theta. Sine square theta plus cosine square is 1. Sine square theta cosine square is 1. So you have dx d theta square plus dy d theta square equal dr d theta square plus r square. Now what do you have, guys? Here you have dx d theta square plus dy d theta square equal dr d theta square plus r square. Now we find arc length for polar curve. Integral a and b dx d theta square plus dy d theta square d theta inside replaced by dr d theta square plus r square. That you have integral a and b square root dr d theta square plus r square d theta. That you find arc length for polar curve. Another way, square root dr d theta, meaning is f prime theta square, r meaning is f of theta square. Let's find the arc length of this circle. Theta is gonna be pi over 2. So this one is a circle with radius gonna be this is the diameter is 4, radius gonna be 2, guys. Let's find that. So integral a and b dr d theta square plus r square d theta. R is 4 cosine theta, r prime gonna be negative 4 sine theta. Where to where? Theta gonna be 0 and pi over 2, integral 0 and pi over 2, square root negative 4 sine theta square plus 4 cosine theta square d theta. Negative 4 sine theta square gonna be 16 sine square theta plus 16 cosine square theta d theta. This one is inside the square root 16. Square root 16 is 4. So integral 0 and pi over 2 for this theta. So find this integration. 4 times pi over 2, that's the 2 pi. So another way you figured it out, this arc length meaning is r equal 4 cosine theta. Theta is 0 and pi over 2, meaning is you have this one. Circumference of semicircle. Circumference of whole circle gonna be 2 pi r. 2 pi r is 2. That's 4 pi. Semicircle gonna be 4 pi divided by 2. That's the 2 pi. Exactly same answer. Let's have one more example for arc length. So r is 1 plus sine theta. We sketched this polar curve. Theta is 0 and 2 pi. So we find arc length formula here, a and b, dr d theta, r prime square plus r square d theta. So we have r prime is cosine theta, r is 1 plus sine theta. So integral 0 and 2 pi, square root 1 plus sine theta square plus cosine theta square. Let's simplify inside. 1 plus sine theta square. When you FOIL it, 1 plus 2 sine theta plus sine square theta plus cosine square theta. Sine square plus cosine square theta is 1. So you have 1 plus 1 is 2. So 2 plus 2 sine theta inside the square root. We cannot solve this integration by hand. You have to use the integration app or graphing calculator. Then we find this integration gonna be 8. What do you learn from this session? First, we learn find area of polar region by using this one. Area gonna be 1.5. Interval of angle r squared is theta. That's the area of polar curve. Second is we study arc length of polar curve. That's gonna be alpha and beta. That's interval of angle. R squared plus dr d theta squared d theta.